What's on the other side of a black hole? Some believe that black holes can be portals to other universes. Believe it or not, that idea is not so crazy as you might think. That is what we will discuss today in our moment of thinking. What is a black hole? Black holes are mysterious and bizarre objects in the universe that really have no explanation in fact. Imagine a grain of rice. Now imagine that this grain weighs more than 10 suns. A black hole is the product of mass being squeezed together, so densely and so tightly that it creates a gravitational pull. That is so strong that not even light can escape its grasp. The diet of known black holes consists mostly of gas and dust, which fill the otherwise empty space throughout the universe. Black holes can also consume material from nearby stars. In fact, the most massive black holes can swallow stars whole. Now it might sound like black holes are dangerous, and that anything that even remotely comes close to a black hole would get sucked inside and be crushed. While it's true that if you managed to carefully drop an object into a black hole, you'd never get that object back. But black holes are actually remarkably bad at pulling materials close to them. Black holes will not actually suck in objects from large distances. A black hole can only capture objects that come very close to it. Imagine replacing the Sun by a black hole of the same mass. The planets would continue to revolve around the black hole at the same distance and speed as they do now. None of the planets would be sucked into the black hole. Our Earth would be in danger only if it came within some 10 miles of the black hole. They're more like cosmic Venus flytraps than Titanic vacuum cleaners. But what happens with the objects that fell into a black hole? Where did they go? Maybe they don't go anywhere. Some say that a black hole isn't actually a hole. That they are only a massive gravitational force that compress matter to levels beyond understanding. That they compress matter infinite times. We don't know what the implications of curving spacetime to infinity really are. Some scientists say that it is possible to curve spacetime all the way round. So that a black hole may end up leading to a completely different part of space. You would then have a link between the two disparate regions which pinches them together, ignoring the cosmic distance between the two. Almost like folding a piece of paper to connect two dots, as opposed to drawing a line between them. To understand how a black hole could act as a gateway, we first have to understand the very nature of space and time. For this, let's take a look in what a humble scientist has to say, Albert Einstein. According to his world-renowned and time-tested theory of general relativity, time and space are fundamentally linked, combining to create a malleable cosmic fabric which lines the entire universe, known simply as spacetime. And we liken it to fabric because it is warped by the matter upon it. The plane of spacetime is curved by the presence of mass. Mass is a form of condensed energy, and where there is condensed energy, spacetime will fold around it. The resulting effect is felt as gravity. The heavier and more concentrated the mass, the more the spacetime surrounding it will warp. And as such, if we compress enough mass within a sufficiently minuscule volume, then spacetime will deform so much that an abyssal, never-ending sinkhole will be created in the fabric. That sinkhole is also called wormhole. A bridge beyond time and space that can connect you to another part of the universe, another time of the universe, or even a whole other universe. No one really knows what lies beyond a black hole. But some mathematicians have a theory. The mathematical model of a black hole indicates that a counterpart should exist. A white hole. As the name suggests, a white hole is the opposite of a black hole. If wormholes in spacetime really do exist, then, for all that goes in via a black hole, there must be another hole somewhere through which all comes out. Even if it only exists momentarily, this would be a white hole. Where black holes consume, white holes would eject. This ejecting event would be tricky to spot, as it would not last for very long. If a white hole ejected too much matter too consistently, then before long its system would undergo a gravitational collapse, forming a black hole in place of the white hole. And so instead it is more likely that a white hole's ejections would be highly infrequent and very brief. Never a white hole was identified by us. Some say that it would look like really similar from a black hole at distance, and it probably would last a fraction of a second, making it very hard to see. But maybe, just maybe, we have identified one. Or at least the consequences of the existence of one. While we've never seen any evidence for a white hole in space, there is one thing that mimics the behavior of one. And that thing is the Big Bang. The Big Bang was an event during which the universe's energy was released in a single pulse. And that energy has been flowing outwards and away ever since. Even today, galaxies and matter are being separated gradually by a mysterious force. Similar to the way in which a white hole would be expected to push matter away. Black holes could look like a massive force of destruction. But, perhaps, black holes are in fact the birthplace of new universes. Perhaps, our universe was born inside one. Perhaps, rather than being portals that could lead us to other points in our universe, black holes could be portals to whole new universes. By considering such ideas, you begin to stumble into the curious paradigm of black hole cosmology, which holds as its key assertion that universes begin inside black holes. Universes which themselves give rise to black holes. And thus new universes, in a never-ending cycle of creation. One of astronomy's great, enduring mysteries is what really happens on the inside of a black hole. Black holes are the most fascinating and mysterious objects in the universe. They are pockets of space which exist outside of the laws of nature, and are places where time and space as we know it cease to exist. What really happens on the inside of one of these universal boundaries remains a mystery. We hope that today's video challenged and expanded your mind. Subscribe to our channel for more moments like that. Now we want to hear from you. Do you have a theory you can share? Where did we get right or wrong? Share with us in the comments section. Until next time.